Okay, this question is about the rate of reaction. This question is about how the rate of reaction is affected by changes in conditions. The student carries out 2 investigations using the reactions between aqueous thiosulfate and hydrogen ions. The student determines the rate of reaction and how it's affected by the changes in concentration. So use the data in the table to deduce the order of reaction with respect to thiosulfate ions and the hydrogen ions. Okay, so starting with the thiosulfate ions, we can see that these two haven't changed. I prefer things to double, so that has gone up by 2 to the x. That has gone up by 2, so my work in here, 2 to the x equals 2, therefore x is 1, so therefore this is first order. Okay, next one, let me just rub this out so I've got space to rework these out. I'm going to put my first order with respect to thiosulfate on here so that I can use that. Now with the next one I have to use run 3. It doesn't really matter what I use apart from run 3, and again I prefer that to double. That has gone up by 4, so 4 to the 1, which is 4. That has doubled, so 2 to the x, and that has gone up by 4 as well. So space for the working. So 4 times 2 to the x equals 4. 2 to the x equals 1. And again, you can just try it on your calculator because x is always going to be 0, 1 or 2. So x equals 0. So 0 order. Use your answers to part A to give the rate equation. So the rate equation is equal to K and then S2O3 2 minus. Okay, part C, the student determines the rate constant for the reaction at different temperatures. We're given the logged Arrhenius equation and we're given the plot, and what we have to do is calculate the gradient. So I've pre-done this just because using the rule is quite tricky, and I want to make sure that I get the readings and read them off correctly. To get the gradient to 3 significant figures, so just give myself a little reminder down here, 3 significant figures. So my gradient is the change in y, so that is the difference between these two values here, divided by the change in x, which is the difference between these two values here, not forgetting that all of these values here are times 10 to the minus 3. Okay, so that should be times 10 to the minus 3, times 10 to the minus 3 there as well. So the gradient is a negative curve, or a negative line, so minus 1.95 divided by 0.33 times 10 to the minus 3 gives me minus 5909. Now, the gradient, you are allowed any value between minus 5,700 and minus 6,100. Okay. So 1 mark for the correct gradient, and then the next part is calculating the activation energy. So the activation energy is minus the gradient multiplied by 8.31, so that's 5909 times 8.31, which let me just work that out. So 5909 times 8.31 equals 49104, that's in joules, so divide it by 1,000, which gives me 49.1 kilojoules per mole. So 1 mark for the working, 1 mark for the activation energy, written to 3 significant figures. From the graph, the student estimates that the value of A is minus 2. Explain why the student has made a mistake. So from the graph, remember the log of A is C. It's the intercept in that y equals mx plus c that we have here. So there's the kind of plus c part there. What the student has done is they've extrapolated this back to get minus 2, but it hasn't crossed the axes at x equals 0. Okay, so it's not a proper intercept. Okay, so the intercept should be at x equals 0, not, as we've got here, x equals 3. Part 3, the student calculates the value of k in investigation 1 as 0.075. Use the graph to determine the temperature. So we've got k. Let's do the log of k. So the log of 0.075 equals minus 2.59. So there's a mark there. And then 2.59. So I'm going to my graph here. So 2.59 is about here, just shy of that line. So take that across to here. So there's the point at which it crosses, which if I read this up here, the value is 3.1. And it's 3.1 times 10 to the minus 3, remember. So 1 over t equals 3.1 times 10 to the minus 3. So 1 divided by 3.1 times 10 to the minus 3 equals 322. So T in Kelvin is 322.6. Take away 273 gives me 49.6. So 49.6 degrees C. Okay, part D, the reaction between two different compounds A and B is studied at a given temperature. The initial rate was found to be 6.2 times 10 to the minus 6. The concentrations of A and B are both doubled. So that means that the rate will go up by 2 squared is 4 times 2 is 8. So I need to multiply that by 8. So 8 times 6.2 times 10 to the minus 6 gives me 4.96 times 10 to the minus 5. And then the units for the rate constant. So in the rate, the moles per decimeter cubed will cancel out one of the three kind of concentrations I've got there, which will leave me with mole minus 2, dm plus 6, seconds minus 1.